So we have 9 students who recently graduated from a small school that has a class size of 9, and they want to figure out what is the central tendency for salaries 1 year after graduation. And they also want to have a sense of the spread around that central tendency 1 year after graduation. So they all agree to put in their salaries into a computer. And so these are their salaries that measured in thousands. So one makes 35,000, 50,000, 50,000, 50,000, 56,000. Two makes 60,000, one makes 75,000, and one makes 250,000. So she's doing very well for herself. And the computer spits out a bunch of parameters based on this data here. So it spits out 2 typical measures of central tendency. The mean is roughly 76.2. The computer would calculate it by adding up all of these numbers, these 9 numbers, and then dividing by 9. And the median is 56. And median is quite easy to calculate. You just order the numbers and you take the middle number here, which is 56. Now what I want you to do is pause this video and think about, for this data set, for this population of salaries, which measure of central tendency is a better measure? All right, so let's think about this a little bit. I'm going to plot it on a line here. I'm going to plot my data so we get a better sense. So we just don't see them. So we just don't see things as numbers, but we see where those numbers sit relative to each other. So let's say this is 0. Let's say this is, 1, 2, 3, 4, 5. So this would be 250. This is 50, 100, 150, 200. And let's say if this is 50, then this would be roughly 40 right here. And I just want to get rough. So this would be about 60, 70, 80, 90. Close enough. I could draw this a little bit neater, but 60, 70, 80, 90. Actually, let me just clean this up a little bit more too. This one right over here would be a little bit closer. So this one, let me just put it right around here. So that's 40, and then this would be 30, 20, 10. Okay, that's pretty good. So let's plot this data. So one student makes 35,000, so that is right over there. 2 make 50,000, or 3 make 50,000, so 1, 2, and 3. I'll put it like that. 1 makes 56,000, which would put them right over here. 1 makes 60,000. Actually, 2 makes 60,000, so it's like that. 1 makes 75,000, so that's 60, 70, 75,000. This one's going to be right around there. And then 1 makes 250,000. So one's salary is all the way around there. And then when we calculate the mean as 76.2 as our measure of central tendency, 76.2 is right over there. So is this a good measure of central tendency? Well, to me, it doesn't feel that good because our measure of central tendency is higher than all of the data points except for 1. And the reason is that you have this one, that our data is skewed significantly by this data point at $250,000. It is so far from the rest of the distribution, from the rest of the data, that it has skewed the mean. And this is something that you see in general. If you have data that is skewed, and especially things like salary data, where someone might make, most people are making $50,000, $60,000, $70,000, but someone might make $2 million. And so that will skew the average, or skew the mean, I should say, when you add them all up and divide by the number of data points you have. In this case, especially when you have data points that would skew the mean, median is much more robust. The median at 56 sits right over here, which seems to be much more indicative for central tendency. And think about it. Even if you made this, instead of 250,000, if you made this 250,000, which would be $250 million, which is a ginormous amount of money to make, it would skew the mean incredibly, but it actually would not even change the median, because the median, it doesn't matter how high this number gets. This could be $1 trillion. This could be $1 quadrillion. The median is going to stay the same. So the median is much more robust if you have a skewed data set. Mean makes a little bit more sense if you have a symmetric data set, or if you have things that are, where things are roughly above and below the mean, or things aren't skewed incredibly in one direction, especially by a handful of data points like we have right over here. So in this example, the median is a much better measure of central tendency. And so what about spread? Well, you might immediately say, well, Sal, you already told us that the mean is not so good, and the standard deviation is based on the mean. You take each of these data points, find their distance from the mean, square that number, add up those squared distances, divide by the number of data points if we're taking the population standard deviation, and then you take the square root of the whole thing. And so since this is based on the mean, which isn't a good measure of central tendency in this situation, and this is also going to skew that standard deviation, this is a lot larger than if you look at the actual, you want an indication of the spread. Yes, you have this one data point that's way far away from either the mean or the median, depending on how you want to think about it, but most of the data points seem much closer. And so for that situation, not only are we using the median, but the interquartile range is once again more robust. How do we calculate the interquartile range? Well, you take the median, and then you take the bottom group of numbers and calculate the median of those. So that's 50 right over here. And then you take the top group of numbers, the upper group of numbers, and the median there, 60 and 75, is 67.5. If this looks unfamiliar, we have many videos on interquartile range and calculating standard deviation and median and mean. This is just a little bit of a review. And then the difference between these two is 17.5. And notice, this distance between these two, this 17.5, this isn't going to change even if this is $250 billion. So once again, both of these measures are more robust when you have a skewed data set. So the big takeaway here is mean and standard deviation, they're not bad. If you have a roughly symmetric data set, if you don't have any significant outliers, things that really skew the data set, mean and standard deviation can be quite solid. But if you're looking at something that could get really skewed by a handful of data points, median might be a median and interquartile range. Median for central tendency, interquartile range for spread around that central tendency. And that's why you'll see when people talk about salaries, they'll often talk about median because you could have some skewed salaries, especially on the upside. When you talk about things like home prices, you'll see median often measured more typically than mean, because home prices in a neighborhood, or in a city, a lot of the houses might be in the $200,000, $300,000 range, but maybe there's one ginormous mansion that is $100 million. And if you calculated mean, that would skew and give a false impression of the average or the central tendency of prices in that city.